All right, so important words. So congruence means same. Theorem means rule. It's just a rule place. Triangle obviously is a triangle. Oh, that's a really terrible triangle I drew. Um, you get the point. I'm gonna try to draw a good triangle. There we go. Um, sides. Sides are these long parts, okay? Then you have angles, which are the parts on the inside like that. And then remember, if you have two triangles that are connected by one line, okay, by one side like this. See how AC is on both triangles? That is the same side for both triangles. So this is going to be the same. So AC for both triangles is the same side. So it's the same. So you can always assume it's going to be the same if it's connected like that. So looking at triangle theorems, these are just your rules. So if you want to take a picture to use throughout the video, I would. So angle, angle, side. You have angle, angle, side. Angle, angle, side. See how they match? Angle, 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 side, side. Then you have angle, side, angle. Angle, side, angle. Then you have side, angle, side. Side, angle, side. Oh, that's supposed to be one line, sorry. There we go. Now they match. So side, 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 all your sides match. Those little lines mean they're the same. So this side is the same as this side. This side is the same as this side. This side is the same as this side. Then hypotenuse, leg. You have the hypotenuse, which is the same, and then the leg, which is the same. Then we're going to get to the actual material. Which diagram contains a pair of triangles that are congruent by angle, side, angle? Congruence theorem. So, looking at my first triangle, I know I have these two sides that are the same. Then I have these two sides that are the same. And then I have this line in the middle, and that means that side is the same. So, if I use my rules, I know these two triangles are congruent by what rule? Very good. Side, side, side. So it's not angle, side, angle, so that can't be my answer. If I look at B, I see that these two lines are the same, and I know that this line is the same for both. But I only know that two sides are the same, so I really can't tell anything from this triangle because I don't have anything else for it. So this can't be my answer. If I look at C, I know this angle is the same as this angle, and this angle is the same as this angle. And then we also know that this line right here is going to be the same. So what theorem can I use to say these two triangles are the same? Very good. It's angle, side, angle. So this may be my answer. It matches. So I'm gonna put a little question mark. Maybe I'm gonna check D just in case. So with D, I know these two angles are the same, and these two sides are the same. Then I know these two sides are the same, and I know it's a right angle. It's a right angle. So we know that this is the hypotenuse. Hypotenuse. I'm not a spelling teacher. Hypotenuse leg theorem. Sorry, that took a little longer. So it can't be D. So my only answer would be C because it's angle, side, angle. So this one's a little tricky because you have to use other rules. In the figure, AB is, what do these two lines mean right here? Remember, that's parallel. Good job. Parallel to CD. Based on the information, which triangle congruence relation proves? Triangle ABC, ABC is congruent to DCB. DCB. Okay, I want to know that those two triangles are the same. So remember, the first thing we need to know is that these two lines are parallel. Okay? These two lines are parallel. And we also know that this line in the middle is the same for both. So we know they have a side that is the same. And I'm going to draw this real quick for you so you remember something. Remember when we did these parallel lines and this angle was the same as this angle and this angle was the same as this angle? So remembering that rule, we can say this angle is the same as this angle and this angle is the same as this angle. So using that, which theorem would make these two triangles the same? Very good. It'd be angle, side, angle. This one you have to apply this and this. It's a little bit difficult, but I know y'all can do it. Oh, this one too. Okay, so in the figure M is the midpoint of AD and BC. Remember, midpoint is the halfway point. So it's in the middle. So it makes this side equal to this side. Okay? So if M is the midpoint of AD, that means this side is equal to this side. Because this is all AD and M is the middle. If M is the midpoint of BC, then that means that this line, this little part right here, is the same as this part right here. Alright? Then you have to apply another rule. I know, there's so many rules. But if you have two angles like this, what happens with these two angles? What happens to vertical angles? Remember that rule, vertical angles? What are vertical angles? They're the same. So that means this angle is the same as this angle. So knowing that we have a side, an angle, and a side that are the same, what rule would I use? Very good. We would use side, angle, side. That would be, hey, side, angle, side. So, which diagram contains a pair of triangles that are congruent by angle, angle, side? Angle, angle, side. Angle, angle, side. So, looking at A, we know we have these two sides are the same, and these two sides are the same. What do we know about this line right here? What do we know about this line right here? It is the same. So, what theorem could we use for A? Very good. Side, side, side. So that can't be my answer because we're looking for angle, angle, side. Then we get to B. We know these two sides are the same. Then these two angles are the same. Then these two sides are the same. So what theorem could I use to say these two triangles are the same? Very good. Side, angle, side. And is that what we're looking for? No, so that can't be my answer. So I'm looking at C. I know these two angles are the same. I know these two angles are the same. And what do I know about this line right here? Very good. It's the same for both triangles. So what theorem can I use to say this triangle, these two triangles are the same? Very good. You have angle, angle, side. And is that what I'm looking for? Yes. So I'll put a little check mark just in case. Then if we look at D, we see that these two sides are the same. These two sides are the same. And it's a right angle. So what rule would we use to say those are the same? Very good. Hypotenuse leg. So D can't be my answer. So it has to be C. All right, so in the figure, triangle ABC and triangle ADC are shown. Based on the information, which triangle congruence relationship proves a triangle ABC is congruent to triangle ADC? So looking at the triangles you're given, I want you to determine what rule we would use. Very good. So we know these two angles are the same. We know these two angles are the same. And what do we know about this line again? It is the same. So you have angle, side, angle. Angle, side, angle. That's what y'all all should have gotten. So angle, side, angle. So it would have been C. Wow, that's a lot. Okay, so I'm gonna let y'all try this one. Go ahead and look at it, try it. Very good. You have two angles that are the same. Then you have two more angles that are the same. And what do we know about this line right here? It's the same. So you have angle, angle, side. Angle, angle, side. So you should have gotten C. You should have gotten C. Which diagram contains a pair of triangles that are congruent by side, angle, side? Side, angle, side. So I'm gonna let you try this one by yourself. This is supposed to be A. I'm gonna let you try this one by yourself. So when you were doing this, you should have seen that these two angles are the same. These two sides are the same, and these two angles are the same, and then these two sides are the same. So it would have been B because you have side, angle, side. Side, angle, side. Very good. Which diagram contains a pair of triangles that are not congruent? That are not congruent. So you're looking for two triangles that we can't use any rule on. I'm gonna let you try this and then I'll explain it. Very good. If it's okay if you didn't get the right answer, but I'm gonna explain it real quick. So you have side side, then you have side side, then we know that this line means they're the same. So this would have been side, side, side. Then going to the next one. You have these two sides are the same. You have these two sides are the same. And you have these two angles are the same. So you would have used side, angle, side. Side, angle, side. Then going to the next one. So this is true and this is true. So going to the next one, you see these two angles are the same. You see these two angles are the same. And we know that this side is the same. So you would have used angle, 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 side. Angle, angle, side. So this does have a rule too. But looking at D, you have this angle is the same, angle, angle. Then you have this angle is the same as this angle, and this angle is the same as this angle. Angle, angle, side, or no, angle, side, side, angle, side, side isn't a rule. That's not one of our rules. So we know it has to be D. This does not work. Angle, side, side is not a rule. It's time for our favorite part of the day. All right, y'all ready? I know you're ready. Okay, let's see. Okay, so we got the body right here, a little neck, some little feet. That's some bad, like those are bad feet. I'm sorry. Um, some more feet. Then I think y'all can get this one. This one's easy. Maybe not. What did Fisher draw? Nay? I think they say nay. Yeah. All right, what did I draw?